So from here, so let's copy this one. So okay, so you have negative 2 here, raised to the power of negative 2. Then we multiplied it with negative 2. So negative 2 times 2, you have negative 4 over x, which is equal to negative 6. 3 times negative 2 is negative 6, x raised to the power of 2. So therefore, we have this equation already, which we will use. Okay, so let's use this. So this is the equation that we will be using, okay, to get our PTX and QTX. So again, so from here it is clearly we could see that our PTX, sorry, that our PTX, okay, so our PTX is equivalent to this one, negative 4 over x, because that is x, right? PTX. So this is our PTX. Why we add t? So that we could identify that this came from the process of Bernoulli differential equation. Next is we can now identify also our QTX, or like that one. QTX is negative 6x squared. So we already have this two. We already have also have this two. So now let me erase some part. So let me erase this part. Okay. Okay, sorry. Erase this part. Okay. So after that, we now can solve. We can now continue. So after that, because we already have our PTX and QTX, what we need to solve in order to substitute in the general solution is just our integrating factor, which is integrating factor, which is integrating integrating factor is equal to e raised to the power of integral of p dx dx. And our ptx is equal to negative 4, which is this one. Okay, this one. So, which is equivalent to integral of negative 4 over x dx. So, solving this one, you will get e raised to the power of, move the negative 4 outside. So, negative 4 integral of dx over x. So, obviously, we know that is ln. So, negative 4 ln of x. So, you have e raised to the power of ln x raised to the power of negative 4. And we know that this one is equivalent to 1. So, therefore, your integrating factor is just equal to x raised to the power of negative 4. So, this is your another, okay, sorry. So now we already have our PTX, QTX, and our integrating factor. So now, recall that our general solution of our Bernoulli differential equation is, and in Bernoulli in y, it looks like this. Because this is Bernoulli in y, we will not put y here, but instead we will put the value of m. Okay, so m dot integrating factor, which is equivalent to integral of q dx times integrating factor dx plus c. That is the general solution. And we know that our m, last time when we try to do it, diba, we divide this one by y cubed. And what remains here, okay, you could scroll it back. So let me show you the documentation. So if you could see here, so we have this one, and this is our y raised to the power of negative 2. So our m is y raised to the power of negative 2. So from there, so we know that our m is y raised to the power of negative 2 times, what is our integrating factor? That is x raised to the power of negative 4 equals integral, what is our qtx? Negative 6x squared multiplied by, this is our qtx integrating factor, which is x raised to the power negative 4 dx plus c. Now we could simplify it further. So we could say we could have 1 over, okay, let me erase a part again of the solution. So we already have our qtx integrating factor and m. So I actually can delete this one already. So we could continue it here. So from here, we have, because this is negative y raised to the power of negative 2 and x raised to the power of negative 4, so we could say that is 1 over x raised to the power of 4 y squared, right? This is x raised to the power of 4, which is this one, x raised to the power of 2, which is this one. That is 1 over, which is equal to, integral of that, we move the 6 outside, integral of x squared times x raised to the power of negative 4 dx plus c. So from there, we have 1 over x squared y squared. So from algebra, we have to simplify this one before integrating. So you have x, 2. So the same variable. So x times x. So the power will be added. So plus negative. So that is added. Plus negative 4 dx plus c. So therefore, what we have is x raised to the power of 4 y squared is equal to negative 6 integral of x 2 plus negative 4. So it becomes 2 minus 4, that is negative 2 dx plus c. So therefore, what we have is y squared equals, integrate this one, you have x raised to the power of negative 2, right, plus 1 over negative 2 plus 1 plus c. That's how we do the power rule, right? So plus 1 over that power. So we have 1 over x squared y squared, sorry, that is 4, equals to 6 x raised to, that is negative 1 over, that is negative 1, this is negative 1, so plus c. So negative, so positive. So what we have is 1 over x raised to the power 4 y squared equals, that is negative negative becomes positive. We have 6. So 6 divided by 1, that is still 6. So negative 6 divided by negative 1, that is positive 6, times x raised to the power of negative 1 or over x plus c. So basically, this is our general solution. Okay? So basically what you need to do is first eliminate the other variable that is not needed on the Q. So by multiplying or dividing, so both sides. After that, you will have to multiply it. The variable here will be derived, which is your m. After deriving, you will have to equate it with the value on the uh, um, top left of your equation. After that, substituting that one, now you could simplify it further, canceling what you need to cancel. Then you can now form your standard form for Bernoulli differential equation, and you can now get your PTX, QTX. After getting the PTX, then you could get your integrating factor. If you already have integrating factor and the QTX, you can now substitute in your general solution for the Bernoulli differential equation. Since it is Bernoulli differential equation, then you need to use the value of m that you get. So after that, you follow the other process. So here, just simply integrating. After that, you will get your general solution. So any questions? So the next one is we will have an example of Bernoulli in X. So if you could see here, this is Bernoulli in Y. So this example is Bernoulli in Y. Let us check whether our answer is the same. So let's try. That is 1x raised to the power 4 over x squared. So we have y. So our QTX is negative 4 over x. So negative 4 over x. So this is our PTX. So our QTX is negative 6x squared. So your QTX is negative 6x squared, which is this one. And then our integrating factor is x raised to the power negative 4, which is integrating for x negative raised to the power negative 4, which is correct. So therefore, let's see if our general solution fits. So here, our general solution, if I'm not mistaken, that is the same. Okay, let's try to look at it. So if you could see, we have 1 over x raised to the power 4 y squared, which is the same here. And we have positive 6 over x. We have 6 over x here. 6 over x plus c. So congratulations! We already solved an example for Bernoulli differential equation. Again, it may have different form at first, but the process will always be the same. The difference there is the simplification to make it look like the standard form of the Bernoulli differential equation. Again, it is more on algebra. How will you come up with the standard form? So by simplifying, dividing in another process and other process. Okay? So we'll have another example which is for Bernoulli in X. Okay?